Hi, I'm Anna, a product manager on the Wear OS team. Today we'll be showing you how to build a high-quality app on Wear OS that stands out and delights users. We'll start by sharing some exciting upcoming features of the platform. Since the launch of Wear OS 3, we've been working to improve the platform with consistent updates, resulting in better battery life and functionality on your current watches. And with the new Wear OS version arriving later this year, we'll bring even more enhancements for the next generation of watches. We're also continuing to expand what's possible with your watch. For example, you'll now be able to check a notification to see who's ringing your doorbell and then remotely unlock the door in the Google Home app right from your wrist. And with new standalone apps for Gmail, Google Calendar, and WhatsApp arriving this year, you'll get more done without ever having to pull out your phone. Now, I'll hand it over to John to share more about what we have in store for developers.
Hi, I'm John, a developer relations engineer on the Android team. In this talk, we'll look at new developments for a variety of surfaces on Wear OS, including notifications, watch faces, Google Assistant, and tiles. First, we'll talk about how users interact with the two types of Wear OS notifications. Next, we'll share an exciting announcement related to watch face development and how a new tool will contribute to an ecosystem of top-tier experiences for the platform. After that, we'll look at how you can use the Google Assistant to achieve a tighter integration with the Wear OS system. And finally, we'll wrap up with an overview of building tiles for Wear OS. Notifications are alerts that are displayed outside of your app's UI to inform users about events from your app. When you're trying to build a high-quality experience for Wear OS, it's important to consider whether you need notifications in the first place, and then how you can make specific adjustments for the wrist. From the user's point of view, notifications need to be relevant, timely, and useful at the moment of delivery. Broadly speaking, notifications on Wear OS use the same APIs as notifications on mobile Android devices, and therefore have the same structure. That said, there are two distinct types of notifications that are common on Wear OS: bridged and local. A bridged notification is one that originates from your mobile app and is delivered, or bridged, from the user's mobile companion app to their Wear OS device. Notification bridging allows users to receive notifications about your app even when they don't have it installed on their watch. Typically, notifications are bridged over Bluetooth, but bridging will still work so long as both devices have an internet connection. You can see notification bridging in action today. If a user has installed messaging apps or email clients on their mobile device that aren't available for Wear OS, they'll still get notifications for these on their wrist. By implementing an Open on Phone action button, these notifications will then be passed off to a user's mobile device for task completion. More specific actions can also be bridged, like this Add to Favorites action. The second type of notification on Wear OS is a local notification. Local notifications are displayed exclusively on the device that created them and are generated independently from any of a user's other devices. In the context of your watch, a local notification is one that is built using the notification APIs in your Wear OS app. Notifications are like other Wear OS surfaces in that they're one of the main entry points into your app. Make sure that tapping a notifications Open on Watch button doesn't just open the Wear OS app, but also takes the user to the relevant screen in your app. When a user dismisses an alert on their watch, the notification should also be dismissed across all of their other devices. This behavior can be implemented by setting a dismissal ID in a notifications wearable extension. Finally, make sure that your notification strategy works even when users have installed both your Wear OS app and your mobile app. It's important to ensure that a user doesn't receive duplicate notifications on their watch for the same event. Check out our documentation to learn more about how to configure bridging options for notifications. And there you have it, a few considerations which can significantly improve the notification experience for users on Wear OS. Let's turn it back over to Anna for an exciting announcement about watch faces.
Thanks, John. A watch face is the first thing that a user sees when they take a look at their watch, making it the most used surface of Wear OS. Watch faces are important for users as it's how they can customize their watch to suit their style and meet their needs. We've been working on a new way to ensure that watch faces can contribute to a high-quality experience on Wear OS. Together with Samsung, we're excited to announce the launch of the watch face format, a new way to build watch faces for Wear OS. The watch face format is a declarative XML format, meaning there will be no code in your watch face APK. The system takes care of the logic needed to render the watch face, so you no longer have to worry about code optimizations or battery performance. Watch faces built with this new format require less maintenance and fewer updates from developers than the ones built using the Jetpack watch face libraries. With the watch face format, we've included the editor as part of Wear OS itself, so every watch face will be customized using the same editor UI. You no longer need to build your own watch face editor for users to customize their watch face. The new watch face format can be used to build watch faces directly, or it can be integrated into watch face creation tools, allowing designers to create watch faces without having to write any code. I'll hand over to Chang Wu from Samsung to tell us some more.
For many years, Samsung has been leading the smartwatch industry and has focused on the user experience of watch faces. 2 years ago, Samsung released Watch Face Studio. Watch Face Studio is an innovative design tool that helps designers to quickly and efficiently create watch faces without programming knowledge. Samsung and Google have been considering more efficient ways to design, manage, and optimize watch faces on Wear OS. This led to our co-developing the new watch face format for Wear OS. Traditionally, watch faces on Wear OS consist of a single package with resources and codes. The resources include images and custom fonts, and the code is responsible for drawing the watch face itself. With this new format, the watch face creator provides an APK containing only resources. The Wear OS platform is responsible for drawing the watch face. No code is required. The resource-only package includes a new resource type, watchface.xml, in which a watch face is defined declaratively. Designer can create this using authoring tools such as Watch Face Studio, and thanks to the open nature of the format, developers are also able to build their own editors, which support the watch face format. This allows creators to focus on sophisticated and unique watch face designs without having to worry about how watch face actually runs or is optimized on the device. The logic is handled by the system, which includes bug fixes and compatibility issues following platform release. So, customers are able to download stable watch faces. There are several key characteristics of the watch face format. The XML schema is centered around the creation of a scene, which is a container for visual tag. Time can be represented in a scene with analog clocks and digital clock. For analog clocks, each hand is represented by a separate image. Digital clock uses a time text child to present a formatted time string. Apart from that, the single structure has two basic nodes, group and part, where group is your logical container and can be the parent of parts. Each part can represent an image, text, or draw type, and this structure makes it easy to design reusable objects with a clearly defined ordering between them. Ambient mode is an important part of watch faces on Wear OS today, but it is not necessary to create an entirely new scene for them. Instead, just change the attributes of a group or part using the variant tag, making a smooth change between active and ambient mode easily. Data values, for example, step count or battery level, can be used as a part of the watch face design. The designer is able to write mathematical expressions and use the result as a value. We call it an expression tag. If designers use this expression tag with the transform element, the result is animated. One of the most helpful features of the watch face format is user configuration. There are many options available for the designer to creatively incorporate user configurable aspect into their watch face, the background, colors, complications, and more. All of these features are supported in the latest version of Samsung's Watch Face Studio. The Watch Face experience will be even better for our users with Watch Face Studio, supporting localization, talkback, complication slot, and health data calling. Samsung and Google are committed to continuing our work together to improve the design and development of watch faces for Wear OS, and to improve the usability of platform overall.
Thanks, Jungwoo. You can get started with Watch Face Studio today by installing it from Samsung's website. John will now walk us through a demo using the latest version of Watch Face Studio.
Let's build a simple analog watch face with the date, a complication slot, and some user style options. Use the Add Component menu to add an index. Use the Add Component menu again to add an analog hour hand. Notice that keyboard shortcuts are available to quickly add components. Use keyboard shortcuts to add the minute and second hands. Use the Properties panel to set the color of the hour, minute, and second hand. To let a user customize their watch face, we'll add a complication slot via the Add Component menu. We can also add text and apply text styles in the Properties panel, such as boldness and alignment. We can use string literals, tags, or a combination of the two for text. First, we'll add the day of the week. We'll duplicate the text element and use it for the calendar date by using the day and month and short text of month and year tags, with a space in between. Watch Face Studio supports user customization of the appearance of the watch face. Let's add a rectangle to use as a background for a new watch face. Move the analog hand layers above everything else so that they're not obscured by other elements. In the Style panel, we'll create a new theme. We'll use the first color for the background, the second for the index, and the third for any text. Now let's add a second theme, which will have a white background, a black index, and black text. We can start to use these theme colors for each of our elements. With our background element selected, we can change its color to white in the Properties panel and set the theme color as well. The base and theme colors are multiplied, so setting the base to white results in 100% theme color. We'll set the index element to white and multiply against the second color in our theme's color palette. Now set text to white and multiply against the third color in our theme's color palette. Do the same with the elements in the complication slot. Same as text color, the third color in our theme's color palette. The Run panel lets us see what our watch face will look like without having it run on a physical device. Here, we can see the different themes in action. Always On mode is a power-saving mode on Wear OS devices. Watch Face Studio makes it easy to toggle the visibility of different elements to hide the ones we don't want to show when the device is in this mode. In this case, we'll hide everything except the hour and minute hands. Testing on a device is easy. We'll use the Run on Device button in the top right corner. Choose a device that's connected via ADB, and click OK on the Launch Complete dialog. You can use the Wear 4 emulator to test your watch face. Open the Add a New Watch Face menu and scroll down to the one you just made. Here, we can customize the watch face before we add it. We can switch between the two themes or swipe right to set the complication slot. Here, we'll choose to display the battery level. We can test the Always On display using the Palm and Tilt buttons. Using the Palm button enables the Always On display, or ambient mode, and all the elements disappear. Pressing the tilt button wakes the device. A high-quality app enables users to quickly engage with their device to complete tasks. Voice commands are an important way to get things done on Wear OS because they enable quick, seamless, and hands-free help, even on a small interface. Google Assistant is built to work seamlessly with Wear OS applications. With App Actions, users can jump straight to the most interesting and helpful points in your application using just their voice. This can be used to conveniently control activities like exercise tracking hands-free so that users never miss a step. To make the development of voice controls even easier, you can use the newly improved Google Assistant plugin for Android Studio. This version of the plugin lets you test your shortcuts file more conveniently than ever before. The shortcut.xml file is where you'll define capabilities that declare the built-in intents that your app supports. By adding these tags in your app's shortcuts file, Assistant can identify which built-in intents are supported in your app, allowing it to trigger specific activities. Here, we're adding a start exercise command with a corresponding shortcut in a fitness app that lets users tell Google Assistant when it's time to go for a jog. To test these capabilities, it used to be necessary to upload a new app version to the Play Store to manually verify any new behavior on a physical Wear OS device. Now, thanks to the Assistant plugin's built-in test tool preview, you upload your app once and then test locally as many times as you need. To speed up development even more, you can now test updates to your App Actions configuration directly in Android Studio by invoking them on the Wear OS emulator. Finally, the App Actions test library enables developers to test app action fulfillment programmatically. This means that now you can run tests automatically without needing to perform manual voice queries or invoke the Assistant plugin by hand. Developers can now use a testing framework to comprehensively test scenarios like this one, which verifies that for a given intent, the fulfillment method includes the expected intent in the returned result. The App Actions test library significantly reduces the need for manual testing, helping developers to build high-quality experiences for Wear OS with less effort. Now back to Anna to introduce some new tiles behaviors.
Thanks, John. Tiles are a surface on Wear OS that live just one swipe away from the watch face. They're one of the fastest ways to get things done or launch an app on Wear OS. By swiping horizontally from the watch face, you can find tiles from a variety of different apps, such as weather, showing the latest forecast, or Google Maps to quickly start a journey. Users can add and configure tiles in the carousel for easy access to tiles from their favorite apps. Since 2021, we've been working with developers to build tiles for their users on Wear OS. Today, we're excited to showcase some new and upcoming tiles from our partners, Spotify, Peloton, and WhatsApp. Each of these tiles have been built using our easy-to-follow design principles to make helpful information or actions accessible with a glance or a tap. John will now take us through creating a tile using the Tiles API.
Tiles are rendered and updated by the Wear OS system, not your app. To add a new tile, create a new service and register in your Android manifest. This newly created tile service will provide information to the Wear OS system that it will use to request the initial tile layout and perform periodic updates. To accomplish this, you'll implement onTileRequest, which will define the tile's layout and bind data to it. Creating a tile requires creating a timeline. A timeline allows the system to refresh your tile less frequently, which is helpful to preserve battery. Timelines are a useful way to show time-sensitive messages, especially when you know in advance what data you need to show at a certain point in time. For example, in a calendar app, you might want to display data about an upcoming event 10 minutes before the event starts. For tiles that can't provide this sort of data in advance, create a timeline with a single entry, like so. To create the user interface for a tile, we recommend using the Tiles Material Library. This library has components that are pre-styled to match material design guidelines. It also provides optimized layouts, which can help you get the most out of the space that's available on a watch face. Include these layouts as part of a timeline entry. As an example, let's consider a step counter feature with a progress arc around the edge of the watch. We can use the edge content layout and create a circular arc to be used as the edge content. Tiles can also show image resources. These can be Android drawable resources generated from canvas drawings or downloaded from the network. To include image resources in a tile, override onResources request in your tile service. When resources are requested for a given version, you can map the resource ID to an image resource. Create these mappings when building your image resource object. Here, we're mapping the weather icon ID to an Android image resource for the rain cloud icon on the left side of this tile. In the tile layout, we set the weather icon ID as the resource when we define our image element. This lets the system know which image resource should be displayed. Tiles are updated when they are visible, or when they are one swipe away from the visible screen. This is controlled by the Wear OS system to prevent excessive updates, which can be harmful to battery performance. Here, the chart and contacts tiles are both updatable since they are both one swipe away from the visible watch face. You can define a freshness interval to describe how long until your tile should be considered stale. This is used by the system to know when it should request an update. Ideally, this value should be greater than 1 minute, as the system may throttle updates for shorter intervals. This interval is inexact, so be sure to design your tile to keep a valid state even when it hasn't been updated recently. In addition to defining a freshness interval, you may also request an update to your tile from your app. You can get an instance of the tile updater using the application context object. This is useful if you're updating data after fetching it. However, it's still subject to visibility and potential throttling constraints. If you request an update too soon, then an update will be scheduled for the next eligible opportunity. Conveniently, you can request updates explicitly and also specify a freshness interval. The last tile update mechanism is a load action, which is used to load or reload the tile contents. To create a load action with an ID, use the Action Builders class. Then pass the load action as a clickable to your intended UI element, a chip in this case. When the user taps on the clickable element, on-tile request will be triggered to update your tile. And that's it. I'll hand it back to Anna to share what's next for tiles.
Thanks, John. Tiles 1.2 introduces support for platform data bindings. This means that if your tile uses platform data sources, such as heart rate, step count, or time, it will be able to update once per second. The new version of Tiles also adds support for animations. You can use tween animations to create smooth transitions on changes to part of your layout. And transition animations can animate new or disappearing elements from the tile. These APIs are ready to try in the latest version of Tiles. We're excited to see the tiles that you'll build. Thank you for joining us today to hear all about what's new for Wear OS. We can't wait to see the new experiences that you'll create across notifications, watch faces, Google Assistant, Tiles, and more. To get started building for Wear OS, go to developer.android.com/wear. For the latest developer updates, including our new Wear OS gallery, where you can find guidance, designs, and case studies. Thank you for watching.